Hi, my name is Mohammed Hazi Aiman Faisal. My matrix number is AA200601. Today I would like to presenting introduction, statistical technique for analyzing and summarizing relationship between two continuous quantitative variable. One variable denoted X is regarded as the predictor, explanatory or independent variable. The other variable denoted Y is regarded as the response, outcome or dependent variable. Because the other titles are less often used nowadays, we refer to the variable encountered in this course. As predicted and response, the other words are merely presented so that you are aware of them in case you come across them in other domains. Simple linear regression gave its name from the fact that it simply look, looks at one predictor variable. Multiple linear regression, on the other hand, which we cover later in this course, take its name from the fact that it involves the analysis of two or more predictor variables. Then, types of relationship. Before we go any further, it's important to understand what kinds of connection we want to be covering in this course, particularly the deterministic or functional relationship. An example of a deterministic connection is shown below. That is, if you know the temperature in degrees Celsius, you can use this equation to determine the temperature in degrees Fahrenheit exactly. Here are some examples of other deterministic relationships that students from previous semester have shared. For each of these deterministic relationships, the equation exactly describes the relationship between the two variables. This course doesn't examine deterministic relationship. Instead, we are interested in statistical relationship in which the relationship between the variables is not perfect.
Okay, Assalamualaikum. My name is Wan Alif Najmi. I will talk about the filler table. The first one is fact. Fact is the one that we got from the question. So, my first fact is record information from nutrition label of many type of snack food. Second is minimum data needed is 25. This is I got from the question. Then collect fat content per serving and calories per serving. Okay, next is the ideas. Ideas is our ideas to answer the question. First is analysis the data from the nutrition label of the snack. And then the second is find the relationship between fat content and calories for each serve. And the last one is use simple linear regression formula, the one that we learned in our class. Okay, and then the learning issue is the issue that we need to answer to get the question. The first is what is the relationship between fat content and calories. Next is how many fat content and calories per serving in each snack. Okay, the last one is how to create a scatter plot for the data. Okay, the last one is action plan or resources need. First is go to the 99 Speed Mart to find information on variety of snack, which is our group. Go to the Speed Mart to find the snack. And then the second is YouTube simple linear regression so that we can answer the question. And last one is lecture slide, which is simple linear regression.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul Mahiri, Geometry AA200310. Okay, for this project, I will tell about the problem and solution about this project. Firstly, I want to show the data of the fat content and calories from the nutrition label that we take from the snack. For the question for this project, first, create a scatter plot of this data between fat content and calories and describe the relationship. Second, in the scatter plot you made, what are the explanatory variable and response variable? In a short answer, why you want to construct this problem by using a simple linear regression. For the third, fit a simple linear regression. Write the fit model using mathematical notation and interpret the slope and intercept and sketch the line. And the final question is find and interpret the value of R2. Answer for question 1. This graph is the scatter plot of relationship between fat content and calories per 100 gram. For this scatter plot, we take x direction is the fat content while y direction is the calorie. The relationship between fat content and calories is fat is a nutrient that has more than twice as many calories per gram as carbohydrate and protein. A gram of fat has 9 calories while a carbohydrate and protein has 4 calories. Calorie is the energy that is released when your body digests and absorb food. When you eat more calories, your body can extract calorie as body fat. Excess calorie in any form can be stored as a body fat. So, the more fat content in the food, the more calories that has in the food. Answer for question 2. The explanatory variable of this project is the fat content per 100 gram, while the response variable of this project is the calories per 100 gram. Okay. Next, why we gonna use a simple linear regression to solve this problem? Firstly, we use simple linear regression because this can know how the dependent variable change if the independent variable change. Other than that, we can know the relationship between the fat content and calorie is a positive, negative, linear or curvilinear relationship. And the last one, we can know the strength of the relationship between of two nutrients, that is fat content and calories. So that's all from me. For the answer question 3 and 4, I will pass to the Hafiz.
So I would like to talk about question number 3 for statistic. So we have a table here. So the table will be include x square, y square and xy. So we need to calculate the value of x square, y square and xy for the whole information. Then we need to do some calculation, which is sxx and syy and sxy. So the formula is the value of x square minus the value of x divided by the n, and it goes to the yy and xy. Then we need to find the r. So to find the r, we need to divide the value of sxy with the value of xxx and multiply by syy and square root the answer. So the value is 0.742. It is a strong positive linear because the range between the number is 0.5 till 1. Next, we need to find the b1. So the formula for the b1 is sxy divided by sxx. Then we got the value is 9.54562. And then we need to find the b0. The b0, we need to divide the y with the sample, the n, and minus the b1 times sx divided by the n sample. Then we got the value, which is
256.562x. Then we need to find the y by the formula, which is 9.54562x plus 256.5628. Then we need to find we just put the value of the x, which is 70, and we get the value of y. So this is the graph of the SSS and SXY. So this is the graph. Question number 4, we will need to find the r square. So the formula of r square is sxy square divided by the syy multiple sxx. So we put the value of the sxy and sxx and sxy. Then we will get the value of 0.5504. Then the value of 0.5504 is in the range between 0.5 till 1. So it is shown that this calculation is strong positive linear relationship.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zahinuddin, and today I will present about discussion and conclusion. Based on the 29 data sample, the application of simple linear regression model knowledge has been implied in our problem. A scatter plot of the association between fat levels and calorie per serving was created using the 29 data sample and demonstrate a positive connection between the variables. From the solution, the value of xxx, syy and xxy are 3165.88, 514,333.78 and 29,937.291, and the value leads to our sample of correlation coefficient value r, which is 0.742 and in the range of strong positive linear relationships. After that, we find the fit regression line by using the least square method based on the formula y equal to beta 1 plus beta 0. As a result, the suitable linear regression line based on the equation may be sketched. Y equal to 9.4562 times x plus 256.5628. Besides, the value of the coefficient of determination r square is 0.5504. This value is accepted because it is not near to 0. It shows that the model observed only 55.04% variability of calories by explaining the linear relationship between the fat content. This leads to the conclusion that the link between fat content and calorie consumption may be calculated using basic linear regression, in which the value of an output variable can be anticipated based on the value of an input variable. This investigation also yields a good result demonstrating that regression may be utilized to estimate how a dependent variable changes when the independent variable is changed. That's all from me. Thank you.